Hi everyone! Welcome to the second part of the video for this week. We'll talk about categorical syllogisms and using Venn diagram tests to determine their validity or invalidity in this video. So that'll finish up our discussion for the week. Let's just get started. So what we're going to talk about instead are what are called categorical syllogisms. And again, this is one of the oldest forms of argumentation. This goes back to Aristotle. Categorical syllogisms are going to be cases where we have three different categorical statements and three different categories that are being related within those statements. So let's look at a specific example first, and then again we'll sort of break down how to talk about these step by step. So we've got all cats are mammals, we've got all mammals are animals, therefore all cats are animals. And so here would be an example of a categorical syllogism. We've got three classes, cats, mammals, and animals, and we've got three sentences, two premises, one conclusion. All right, how about validity? How can we test that in this case? Well, we're going to use what's called a Venn diagram test to determine validity. The first step of this test, we're going to do what's called standardizing the syllogism. We're going to replace the individual classes with variables. And the reason for this is that validity, remember, it's a purely formal notion. The only thing we care about when we're trying to figure out if an argument is valid or not is the form of the argument, and every argument that has the same form will have the same validity or invalidity. So we're going to replace the specific classes so that we're looking just at the form of the argument so that we don't get basically distracted by the specific content of it. So here's how we're going to do that in the case of these syllogisms. First, go to the conclusion. We're going to replace the first class in the conclusion with an S. That's the subject class of the conclusion. That's what the S stands for. Then we're going to replace the second class with a P. That stands for the predicate class of the conclusion. Then you go up, replace S and P where you see it within the premises. The remaining class we're going to replace with the variable M. M stands for the middle term. It's the term that's not present in the conclusion, but it's a term that connects S and P to one another. Once you're done with that, you can then turn to the Venn diagram test. So before we turn to the Venn diagram test directly, let's just talk about how to diagram each of the four kinds of categorical statements just on their own. Then we can worry about how they sort of relate to one another. So let's start with the universal, so all S is P. If we were just going to diagram this particular sentence, here's the format we're going to use. And this is a little bit conventional. There's a couple different ways you can do it. We just all have to be using the same conventions so we know what the diagram means. And here's a little hint. Whenever you're filling in one of these Venn diagrams, the circle that you're going to be sort of marking in, or the circle you're going to be working on, it'll always be the first circle, the circle for the first class in the categorical statement that you're looking at. So if we're looking at all S is P, you're going to be looking inside the S circle. All right, so what does it mean to say that all S is P? Well, it means that there's no S that doesn't also fit within P. Any part of S that's outside of P, it's empty. There's nothing in that part of the circle. We're going to symbolize that by shading in that region. And so now the only region of S that's left is the region that's completely contained within P. Similarly, when we're looking at no S is P, same basic idea. No S is P means that the region where S and P intersect one another, that region is completely empty. There's nothing in it. We'll symbolize that by shading that region in. So now the only S that's left is the S that's not part of P, the S that doesn't overlap with P. Similarly, we get the sum S is P. Remember, sum means at least one. So what does that mean? It means there's at least one thing where S and P overlap. We're not going to symbolize that with any kind of shading. Shading is going to be reserved for the universal statements. For the particular statements, we're going to draw an X to symbolize that one S that is a P. There could be more, but we know at least one is. So we're going to put an X where S and P overlap. That one X both is S and it's also a P. Same idea with sum S is not P. Here we know there's at least one thing in S that's outside of P, that's not a P. So we're going to symbolize that by putting an X outside of the region where S and P overlap. At least one S is not a P. Which one? The one we've symbolized with our X. What we do now for our Venn diagram test for categorical syllogisms, you're basically just going to take those four different diagrams and use them to diagram your two premises in a three-circle Venn diagram. Here's a few little tricks before we even look at an example. There's a few things. never actually draw the conclusion in the Venn diagram. The only things you should be drawing in the conclusion are the two premises. And the reason for this, we'll see at the end. The way we're going to check for validity is we're going to see if when we already wrote our two premises down in the Venn diagram, have we already written the conclusion down? If you diagram the conclusion, everything will turn out to be a valid argument. So don't ever diagram the conclusion, just diagram the two premises. As a result, you're only ever going to make two sort of, marks, quote unquote, in your Venn diagram. And by a mark, I mean either shading in a region or putting an X down. You're only ever going to have two marks in a Venn diagram. Each premise is only going to ever have one mark. So either an X if it's a particular premise, or you're going to shade in some region if it's a universal premise. Last little hint, last little piece of advice. If you have one premise that's universal, so it's either all or a no, and one premise that's a particular, a sum and a sum or a sum not, always diagram the universal premise first. It'll just make your life a lot easier if you do the universal first. If both of the premises are universals and if both of them are particulars, it doesn't matter. Work in whatever order you want. I'll always work top down. But if one is particular, one is universal, do the universal one first. It'll make your life much easier going forward. All right, so now let's show an example of using Venn diagrams with the argument that we're checking. So we've got all S is M, all M is P, therefore all S is P. Both my premises are universals, so the order I do them in doesn't matter. Let's just start with all S is M. We said what that should look like. We should shade every part of S that's not also contained within M. So I'm looking at my three-part Venn diagram. I look inside the S circle. I'm going to shade out every part of the S circle that doesn't overlap the M. So I'll shade in this region that's not part of either M or P. And then I'll also shade this part where S and P overlap, but don't overlap M. I've shaded out every part where S does not overlap with M. Then go to the second premise, all M is P. I do the exact same thing. I shade in every part of the M circle that doesn't overlap with P. So I shade in the region of M that's all by itself, and then the region of M that overlaps with S, but doesn't also overlap with P. And then I stop. Report, no more. You're done. You've done what you need to do. You've made two marks, two different instances of shading. If it's helpful for you, feel free to use different color pencils or different color markers or whatever to sort of symbolize the two instances of shading. All right, what next? What's the last step? Now we check and see, is this actually a valid argument or not using our Venn diagram. The trick is going to be valid means if the premises are true, then the conclusion is true. Here's another way you can think of that. Think of that as saying that if I say the two premises, I've already said my conclusion. So the question is then, we've said the two premises, right? We filled in the Venn diagram for each premise. Have I also said the conclusion of the argument? Have I also said that all S is P? Well, what would it look like if I had said all S is P? Again, we can go back. It would look like all of S that's outside of P is shaded in. It's made empty. The only part of S that's left is a part of S that overlaps with P. So let's look at my Venn diagram. Is there any part of S remaining, any part of S that's not sort of shaded in, that doesn't also overlap with P? And the answer is no. The only part of S that remains is this one piece in the middle. That piece does indeed overlap with P. So all S is P. I've got a valid argument. I also had all true premises. If I have a valid argument with true premises, I've then got a sound argument. And I can know that the conclusion is necessarily true. All right, let's do one more example of a Venn diagram, and then we'll talk about it more in class. So we'll call it for today once we're done with this. Here we go. All cats are mammals. Some mammals are two-legged animals. Therefore, some cats are two-legged animals. Now, right away, something should strike you as a bit weird. That conclusion seems false, right? I mean, a cat might happen to have two legs, but no cat is a two-legged animal. Right? Humans are two-legged animals, but cats are not. Don't worry about that. Sort of just, that's going to matter eventually in terms of how we evaluate this argument, but at least at the start with, that sort of should not be a factor in your analysis. Your analysis of the argument should proceed by figuring out if the argument is valid and if the premises are true. Because let's say this was a conclusion you didn't know was true or false. What matters is, are the premises true? Is the argument valid? That will tell you if the conclusion has to be true or not. So let's just start again. Let's check and see if the premise is valid. Is it true that all cats are mammals? Yep, we said that's a biological fact. Is it true that some mammals are two-legged animals? Hey, mammal! Yep, looks like two-legged to me. All right, seems to be true. Human beings would be an example of a mammal that is a two-legged animal. So I've got true premises. Let's now check validity. We begin, formalize the argument. Again, we replace the subject term in the conclusion with S, so cats, S. Replace the predicate term of the conclusion with P, so two-legged animals with P. And then finally, we'll replace the middle term, the term that's not in the conclusion at all, with an M, so mammals with M. Right? And we've got our sort of standardization. So now let's do the Venn diagram part. In this case, I do have one universal premise and one particular premise. So it'll be imperative we start with the universal premise. We start with all S as M. Make life way easier doing it that way. All right, so how do we diagram all S as M? Well, we've already seen this. We'll shade in every part of the S circle that doesn't overlap with the M circle. But we haven't really done a particular yet, so let's talk about those. Let's say now we have some M as P. What should this look like? Well, based on what we said before, this should look like putting an X where M and P overlap. Okay, so let's try to do that. We've got a problem here. Which region where M and P overlap should I put my X? Should I put it in the center region, or should I put it in the region that's off to the side? Well, what are my options? Maybe I could put an X in both of those? Nope, don't do that. Can't do that. You can only ever put one mark down for each premise. So for particular premises, you can only ever put one X down. So you can't put it in both of them. That wouldn't work. Okay, so do we just pick one region? Well, no, you can't really do that either, because you don't know which region it actually goes in. Remember, with validity, we have to be dealing with certainty, not just possible or a good guess or something. You would have to know precisely which of these two regions to put the X in. All right, so we don't know which region to put it in. Where should it go? The solution we're going to use, we're going to put the X on the intersecting line between the two regions where it could be. Since the X could be in either of these two regions, we'll put the X on the line between the two of them. That way, we're only putting down one mark for our premise, but we're also at the same time indicating our uncertainty about precisely where the X should go. Right? And now we can stop. We've done our task. We've diagrammed both of our two premises. Now we check and see, have I already said the conclusion by saying those two premises? So what should it look like? The conclusion is that some S is P, so there should be an X in the intersection between S and P. Do we see that? Well, no, we actually don't. There's no X in that top region. There can't be. We know there's nothing in there, but that's fine. Is there an X in that center region? Well, no, there could be an X in the center region, but there doesn't have to be. The X could be in the center, or it could be in that region adjacent to it. So we don't actually see the conclusion. We don't see an X for sure definitively where it needs to be. So when we've said our two premises, we have not necessarily said the conclusion. That means the argument is invalid. That's why we were able to get a sort of obviously false conclusion out of two true premises. It was because of the invalidity of the argument. We can sort of figure out where things went wrong as a result. All right, that'll do it for this video. We're going to spend pretty much the entire class session just doing these Venn diagrams and working on checking validity with the categorical syllogisms. So that's where we'll focus our time in class. There won't be an exam this week. We'll do an exam combining the two different kinds of deductive arguments that we're going to look at next week. All right, I'll see you in class. Hope you're doing well. Bye.